Hey guys, hope you're all doing well. So what I want to do today is just go over the second half of that review that I gave you on Monday. So on Monday, I know we did all the odds. Today we're going to run through all the evens. Like always, guys, if you have any questions, just please contact me through email or Google Classroom, and I'll get right back to you to help you out on this stuff. Or you can always join the Google Meet session too. All right, so first one we're going to start out with is problem number 2. So when we go through and solve this one, because we only see this one cosine in our equation, that tells us that we want to get that by itself. So in order to get that by itself, what we're going to do is we're going to first start off by just adding 1 to both sides. Then we're going to go ahead and divide by 2. And that's going to leave us with a cosine squared x is equal to a 1/2. All right, similar to yesterday, once you guys are here, remember you have to get cosine by itself and not cosine squared. So that just tells you that you're going to have to take the square root of both sides. So when you take the square root of both sides, it leaves you just with a cosine. Just make sure you guys have that plus minus sign. And the square root of 1, is 1, but the square root of 2, which we have on the bottom, is just going to be root 2. All right, so here's the issue that I saw a lot of last week. When you guys get to this point, this is still a special angle, but in order for you to figure out that it's a special angle, you have to try to get rid of that square root on the bottom. So what you have to do is multiply by root 2, because we know root 2 times root 2 just gives us 2. And whatever we do to the bottom, we do to the top. So when we rationalize that fraction and get rid of that square root sign on the bottom, you're just going to end up with a cosine x is equal to plus minus root 2 all over 2. And that's what leads you to that special angle. Because now what we're saying is, in this case, since we're working with cosine, we're saying that our x value has to be root 2 over 2. And the only time that's true is when we are working with the angle of pi over 4. So we know we're working with pi over 4. And if we think about the quadrants that we're in, since we see that plus minus sign, in this case, we will be in all 4 quadrants. So when we go through and we solve for x and we write out all 4 of our angles, quadrant 1 is going to give us that pi over 4. Quadrant number 2 is going to give us 3 pi over 4. Quadrant 3 is going to give us 5 pi over 4. And then that last quadrant number 4, we're going to end up with an answer of 7 pi over 4. All right, so those would be our 4 answers for this problem using a special angle. Again, just be really, really careful of this step right here, making sure that you know that that's actually a special angle when you go through and multiply the bottom and top by that root 2. All right, so let's take a look at 4. So when you guys look at problem number 4, big thing that stands out is you see 2 different sets of tangent. You see a tangent square to start, and then just a tangent to the first in the middle. So anytime that we see especially 2 tangents or 2 sines or 2 cosines or anything more than one going on, we want to be able to factor. So same thing here. Now, since you see a tangent squared, then a tangent to the first, then a number by itself, when you go to factor this is going to factor into your 2 sets of parentheses, which are both going to be equal to 0. So we're going to start both parentheses off with just a tangent x, because there's no number in front of that tangent squared. And then our factors of 6 to give us this -1 that's in the middle is going to be 3 and 2. And then to get -1, the 3 has to be negative, and the 2 has to be positive. All right, so once you have this factored, now you're going to take a look at each factored set, and you're going to set each of those groups equal to 0 and solve for tangent. So when we look at our left side, we're going to end up getting tangent x is equal to a positive 3. And when you look at your right side, you end up getting that tangent of x is equal to a -2. All right. Okay, so once you guys are at this step, Now, again, here's where you want to identify, am I working with a special or non-special angle? Since tangent's equal to 3 and tangent's also equal to -2, 3 and -2 are definitely something that we don't recognize. So here's where we need to actually go through, use our calculator to help us identify what this special angle is going to be. So remember, in order to get that reference angle, you guys are now just using the inverse, and just make sure that you're in radians in your calculator to get the correct inverse. So when we find our inverse, like for example, we're going to have the inverse of tangent of 3, and that's going to give us our reference angle, which in this case is going to be 1.249. And then also when we think about our quadrants, since this 3 is a positive 3, we know tangent is positive in quadrant number 1 and 3. So when we go through to get our two answers from that left side, we end up getting 1.249 and then 4.391. Because since we were in quadrant 3, we had to add on that 1.249 to our closest x-axis over here, which is pi. All right, now we're going to do the same exact thing for the right side. So you guys are going to have to use your calculators, and to find that reference angle, do the inverse of tangent. Remember, keep that 2 positive. You're not putting in -2 yet. And that's going to give us a 1.107. Now, where that negative is a factor or comes into play is now we know that y over x is in quadrant number 2 and quadrant number 3. So now we're going to use that 1.107 and our closest x-axis to help us find where we're at. So in quadrant number 2, we're going to end up with an angle of 2.0. Oh, that was really messy. Hold on. We end up with 2.035. And then on quadrant number 4, we end up getting 5.176. All right. So just again, be careful when you guys are working with either special or non-special angles, and make sure you can identify both. All right, so let's look at number 6. So when you look at number 6, we have 2 sine to the 4th minus sine squared x is equal to 0. All right, so when we're doing this problem, really similar to what we talked about, since we see 2 signs occurring, that tells us that we're going to have to factor. Now, I'm not going to factor this like I did on problem number 4. Anytime we look to factor, we always look for GCFs, right? So in this case, I want to take out a greatest common factor, which is just going to be a sine squared x. So when I take that out, I'm now left with 2 sine squared x, and a sine squared away from sine squared just gives you 1. All right, so now that you're here, now this is, at this point, really similar to the last problem, because now here's our 2 groups where we're going to set each of our groups equal to 0 and try to solve. So when we set sine squared x equal to 0 and we solve by taking the square root, remember, 0 is not really positive or negative, so it just gives us sine x is equal to 0. Over on my second group, when I set that equal to 0 and solve, I'm going to end up getting a sine squared x is equal to a positive 1/2, which then at this point, here's where we're going to have to go through. And to get sine by itself, we're going to have to take the square root of both sides. So this is really similar to what we did on that on problem number 2 to start. So that's going to give us sine x is then equal to a plus minus 1 over root 2. Remember, you got to get rid of that root 2 on the bottom by multiplying the bottom and top by the square root of 2. So this is really going to be sine x is equal to a plus minus root 2 over 2. All right, so if we just focus on the left side first, what it's telling us, since sine x is equal to 0, remember, sine really goes with y, so what we're saying is that y is 0. So we got to figure out the points where y is going to be 0, and in this case, it's going to be 2 points. It's your positive and your negative x-axis. So 2 of your answers are going to be, let me write it over here. So 2 of your answers from this left side are x is equal to the angle measure of 0 and pi. All right, now when we look at our right side over here. Now in this case, when we go through and we think about what angle we're working with, since we're still working with sine, but sine, or y in this case, is root 2 over 2, we know we're working with pi over 4. Then when we go through to figure out our quadrants, since we have that plus minus, that tells us that we're going to be in all 4 quadrants. So quadrant number 1 is going to give us pi over 4. Quadrant number 2 is going to give us 3 pi over 4. Quadrant number 3 is 5 pi over 4. And then quadrant number 4 is going to be 7 pi over 4. So this one ends up having 6 answers because of that plus minus that you had to do on that second part, or that right side, once you factored. All right, looking at number 8. So number 8, we see tangent squared x minus 1 is equal to 0. So like I said before in the first two problems, anytime you see just one trig function in that equation, just get it by itself. So in this case, we want to just add 1 to both sides. So we're going to end up getting tangent squared is equal to 1. Now to get tangent by itself, you're going to have to go through and take the square root of both sides. So that's going to leave us with a tangent x is equal to, don't forget that plus minus, tangent x is equal to plus minus 1. So now what you want to think about is, since we're working with tangent, well, when can we put our y over x value and it give us a value of 1? Don't worry about the plus minus right now. So if we think about all of the ordered pairs we have, the only case that that's true is for the angle measure of pi over 4, because root 2 over 2 over root 2 over 2 gives us 1. So we know we're working with pi over 4. And then when we think about the quadrants that we're in, since we see this plus minus sign here, just like last problem, that's going to tell us that we're in all 4 quadrants. So my final answers for this problem are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, so those would be our 4 final answers. All right, looking at number 10. So number 10, we have 15 sine squared x minus sine x minus 6 is equal to 0. All right, so first thing, we see a couple signs going on, so it tells us we have to factor. We always look for GCF, which in this case we can't take out. So when we go to factor this one, we're going to have to factor this into our 2 groups or 2 sets of parentheses, which is we're going to set equal to 0. So you have to pay really careful or close attention to that 15 and the 6. So you need your factors of 15 in front of sine. So I'm going to split it up into 5 and 3. And then your factors of 6 that you can multiply with those factors of 15 to end up giving you or adding together to get that -1 that's in the middle. So in this case, if we do 5 times 2, which are on the outside, and 3 times 3, which are on the inside, that's going to give us 10 and 9, we can get that -1. Just the 10 has to be negative, and the 9 would have to be positive. So then from this point, you guys want to go through and set each of these equal to 0 and solve for sine. So if we look at our left side, solving for sine, we're going to end up getting sine of x is equal to a -3/5. And I'm just going to focus on this left side for right now. All right, so once we're there, -3/5, again, doesn't look like something that we can easily recognize, which tells us that in this case, we're again working with a non-special angle. All right, so when we're working with that non-special, the first thing we need to find is that reference angle. So in our calculators in radian mode, we're going to do the inverse of sine of a +3/5, and that's going to give us our reference angle of 0.644. So now once we have that 0.644, let's think about the quadrants that we're in. Since this is a -3/5, that tells me that y is negative because we're working with sine. So in this case, we know y is negative in quadrant number 3 and quadrant number 4. So when we go through and we write, so far at least the 2 final answers that we got from the left side, quadrant number 3, we're going to take that 0.644 and add it to pi, and we're going to get 3.786. And then quadrant number 4, we're going to take 2 pi and subtract our reference angle of 0.644 from it, and that's going to give us 5.639. All right, so those are our 2 answers from that left side. Okay, so let's look at our right side. So same thing, you guys want to solve for sine or get sine by itself. So when we do that, we're going to end up getting that sine of x is equal to a +2/3. which again tells us that we're working with a non-special because 2/3 doesn't look familiar at all. So that means that we're going to have to take the inverse of sine of 2/3 in our calculator to get our reference angle. And that should end up giving us 0.730. Now on the right side, since that 2/3 is positive, that means we would need to think about the quadrants in which y is positive, which is quadrant number 1 and quadrant number 2. So when we go through to write our final answers, another one is going to be 0.730 because that's in quadrant 1. To get quadrant 2, remember, we just have to take pi and subtract that reference angle of 0.730 from it, and that's going to give us 2.412. All right, just be really careful of those non-special angles and how you guys are adding and subtracting by either pi or 2 pi to get those. All right, so let's look at 12. All right, so 12 is actually really similar to the one we just went over, except now instead of like sine or cosine, we now see a secant. So remember, we talked about this on Monday. If you guys have a secant or a cosecant or even a cotangent, at the very end, once you solve for that, you want to flip it to get it to be sine, cosine, or tangent, so that you know if you're working with a special or non-special angle. So on 12, the first thing is, because you guys see a few secants going on, and you see a secant squared, a secant of the first, and a number by itself, you want to factor this, and there's no GCF that you can take out. So you're really just going to factor this by splitting it up into our two groups like we did before. So each parenthesis is now going to start with a secant of x. And we need to think about our factors of 2 that'll give us that -3 in the middle. Well, the only factors of 2 are 1 and 2. And since that 2 is positive, we know both of these signs have to be the same. And to get -3, they're both going to have to be negative. So what we're going to do now is we're going to take each group and set them equal to 0 and solve for secant. So on the left side, when we do that, we're going to end up getting that secant of x is equal to a positive 1. And our right side, we're going to get a secant of x is equal to a positive 2. So this is where I talk about when you're at this step, when you have secant solved for, here's when you want to actually flip secant. And in this case, we know secant always goes with cosine. So you're going to flip the left side, which means you also have to flip the right side, which for the left-hand part of this problem isn't bad, because when we flip 1, it just gives us 1. So then when you think about at this point, what special angle you're working with, or since we know we're working with cosine and cosine's x, where x is 1, the only value that x is 1 is that positive x-axis. So one of my answers is just going to be 0. Now, if I look at that right side of kind of that squiggly line that I drew, same thing. We want to take secant and flip it to make it cosine, but that means that we're also going to have to flip the 2. And when I flip a 2, it's really 2 over 1, so flipping that gives us 1 over 2. So now that we have that 1 over 2, now let's think about, since x is 1 over 2, what angle I'm working with. Well, when our x value is 1/2, we know that's the special angle of pi over 3. And since that 1/2 is positive, that tells us that I'm going to be in quadrant number 1. Sorry, I just messed up. Not 2. We're going to be in quadrant number 1 and quadrant number 4, because that's when our x value is actually positive. So quadrant number 1 is going to give us an angle or an answer of pi over 3. And then quadrant number 4 is going to give us an answer or an angle measure of 5 pi over 3. All right, so in this case, you would only end up having 3 answers for this problem. All right, last one we'll go over is number 14. So on 14, we have 3 cosecant squared x minus 1 is equal to 3. So really similar to the last problem, now that you see another cosecant, at the very end, eventually you're going to flip this to get it to sine. But before you do that, you have to try to get cosecant by itself first. So because we only see this one cosecant in this equation, we just want to solve this like a normal equation, trying to get cosecant by itself. So the first thing that we're going to do is add 1 to both sides. Then at this step, we're going to go through and divide by 3. So we're going to end up getting that cosecant squared is equal to a 4/3. To get cosecant by itself, let's take the square root of both sides. So that's going to give us cosecant x is equal to plus minus. Now the square root of 4 is just 2, and we know the square root of 3 we can't do anything with, so we have to leave that as root 3. Now, I know on the first problem today I told you guys if you have a square root on the bottom, look to rationalize it, look to get rid of it by multiplying by itself. But in this case, you don't have to do that because you'd actually be creating a little bit more work for yourself. Because you're working with cosecant, you know you have to flip it anyway, right? So flipping cosecant is just going to give us sine. So when I flip the left side, that means I'm also going to flip the right side. So by flipping 2 over root 3, I end up with root 3 over 2. So now the reason why I didn't rationalize the denominator is because at this step, that's now a special angle that you guys know how to find and then find the quadrants for. So in this case, since sine is y and it goes with root 3 over 2, we know that we're working with a special angle of pi over 3. And because we have that plus minus sign, just like the last few problems, we know in this case that we're going to be in all 4 quadrants. So when we go to say our final answers for x, we're going to end up with pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And those would be our 4 answers. All right, so I hope this helps for your review. Like I said at the beginning, guys, if you have any questions at all about this or anything else, please let me know. I'll get back to you as soon as I can to help you out with this. But hope you guys have the rest of a good day and prepare for that quiz that we have tomorrow. All right, bye.